Wow! Balloon! Bakit ganon? Bakit lumiliit ang lobo kapag pinipisil ko? Kapag hindi ko naman pinipisil, bakit ang laki?
Eh, yung nga, no? Paano kaya nangyari yun?
Patay nga. Ba? Oo nga. Uy, wait lang. Dahil yan sa Boyle's Law.
Learn chemistry!
Boyle's Law is a basic law in chemistry describing the behavior of gas at a constant temperature. It states that at a constant temperature, when the pressure is high, the volume is low, and when the pressure increases, the volume decreases.
Robert Boyle is the person who discovered that the volume of gas decreases with an increasing pressure and vice versa. And this is what we know as Boyle's Law. Robert Boyle is also known as a leading scientist and intellectual of his day. He was a great proponent of an experimental method. Robert also made an experiment to prove his law, and this is what we call the J-tube experiment.
The formula for Boyle's law is P sub 1 times V sub 1 equals P sub 2 times V sub 2.
Where P sub 1 equals first pressure, P sub 2 equals second pressure, V sub 1 equals first volume, V sub 2 equals second volume.
Vocabulary. Volume, it is a space that the substance occupies. For gases, it depends on container size. Common unit of volume include liters and gallons. Next, we have pressure. It is the force of particles colliding with the container's walls. More collision means higher pressure. For the common unit of pressure, it includes the atmosphere and Pascal.
Temperature. Temperature measures hotness or coldness of an object. The common units are Fahrenheit, Celsius, and Kelvin. Amount of gas refers to the quantity of gaseous substances, which is defined by its volume, mass, or chemical amount of moles.
Let's have breathing as an example. The inverse relationship between pressure and volume in gases is used to move air into and out of the lungs. During inhalation, chest cavity and lungs increase in volume, decreasing pressure inside them and causing air to flow in. During exhalation, the volume of the chest cavity and lungs decreases, increasing the pressure and forcing air out. For the next example, we have a balloon inside a syringe. Cover the bottom of the syringe, then as the syringe is being pulled or when the pressure decreases, the volume of the balloon increases. But when the pressure increases, the volume decreases.
Let us now look at the PET simulation. First of all, since Boyle's law is a constant temperature with a volume and pressure that is inversely proportional, we make sure to press the option for constant temperature. First, we pump gas particles into the small container. Since the container is small, the gas particles are squeezed close together. They collide more often with the walls, which causes the pressure gauge to show high pressure. Next, we increase the volume by pulling the piston to the left. As the space inside gets larger, the gas particles have more room to move around. Collisions become less frequent and the pressure decreases. Then, we pull the piston to the right to make the volume smaller. The particles get crowded once more, collision increases, and the pressure goes back up. Finally, we increase the volume again. The particles spread out, collisions drop, and the pressure goes down again. This clearly shows the inverse relationship between pressure and volume, wherein if the volume decreases, the pressure increases, and if the volume increases, pressure decreases.
So, what did we learn about Boyle's law? It tells us that when you press a balloon, it feels tighter because the air is getting pushed towards a tighter space.
But if you let go, the air spreads out and the balloon stays softer.
That's Boyle's Law. Simple but important in understanding how gases work in our everyday life.